Hi guys, meteorologist Lindsey Slater here. So it was a crazy active week of space weather last week, and I'm going to SWPC's weather page or the Space Weather Prediction Center's page, and you can kind of see a recap of this event, a very complex sunspot here, and you can see just the progression of it if you just look at this little timeline here. All the way through the 1st of February. I did see a lot of information of people saying it's close to what Carrington looked like. It doesn't really matter how a sunspot looks, it's more about what it does. And this sunspot was a flare machine. It really wasn't like pumping out huge CMEs. That's what the Carrington event did. If you're unsure of what that is, it is actually a pretty famous event that happened. We can look at it. I don't want to go to Wikipedia, but so Carrington event, I'm trying to find a good source here. There we go. Always look at your sources. This is the most important thing. So the Carrington event was a long time ago. Like literally none of us would remember this, but it's 1859. There was aurora as far south as Florida. This is a look at the Halloween storm that happened in 2003. This was also I believe it was a G5 event, if I'm not mistaken. But the Carrington event, this was a huge solar storm, and I'll be honest, there was a part of these flares that we had earlier this year that almost resembled the how quickly the Earth's magnetosphere responded, but we were nowhere close to maintaining these conditions. I believe that was like 2 weeks ago when we had that the solar storm. Oh gosh, I can't remember it now. It's going to kill me. I believe it was back in January. And it was when we had everything was pointing north, and it wasn't, the magnetic field was not oriented south. If the magnetic field was oriented south, it would have been horrible for infrastructure. So we were pretty lucky about that. But a storm like this only happens once every 500 years. This is, from NESDIS data. So this is the National Environmental Satellite Data and Information Service. This is from NOAA. This is official information. You guys can check this out. Just, Google what's the Carrington event. Make sure you're getting it from a good source. But you can read all about the Carrington event, but it was humongous. I have seen many, basically many like videos of what the Carrington event looked like, and it is wild. I wonder if I could find like Carrington event simulation. Oh gosh, our teacher, our professor, here it is. I think this is it. So this shows, a specific sunspot. It was huge, beautifully magnetically complex. That is the Earth's magnetosphere right here. Okay. And this is what it usually looks like. We have the night side, we have the day side. And so what happens is the sun beefs up and pushes plasma towards us. And this is how the magnetosphere responds. You can see right here. So this is why we get auroras. These little, uh, you know, I guess clamshells, if you will, they kind of move back and forth like this. And when they do that, they take all that plasma and all that stuff. It goes through those magnetic field lines and deposits as precipitation of aurora, protons, electrons, into the earth. This is why we see auroras, but it also can impact infrastructure with geomagnetically induced currents. These are the reasons why we care about these events. This is a look at beginning of this event. You can see, watch what happens here. So all the magnetic field lines are reconnecting. See, it gets kind of happy again. But now we can watch what I believe eventually, right? I think it's right here is when it gets kind of crazy. So 1 second. Let's go to, so we had an event, I believe, in 2006 that was not great. Here it is, 2006. Okay. So this kind of highlights how the Earth kind of normally looks. And then we go to Carrington. Look at that. That magnetosphere is compromised. I mean, we're talking those clamshells getting all the way down to floor. Look at that. I mean, we lost all the shells. We were down to 2 little shells. That is crazy. And look at the magnetotail, which is the back end here, just shooting off things constantly. It is insane. It is wild. I just think I need to do a lot more research on the Carrington event. It is so fascinating. Okay, that was Lindsay's tangent. So now we're looking at this region that gave us a lot of activity. 4366. This guy was pumping out flares and flares and flares and flares. Tons of these flares. And we had R3 radio blackouts. We had X1 flares. We had an X8 flare. So where is it now? So let's go to the newest. Whoop. Way over there on the east limb. I'm sorry, the west limb. Apologize for that. Way there on the west limb. Now we're kind of looking at active region 4373, 4371. I did notice some filaments that were showing up, and I think we got to look at 193. Nope, 193 is good. I think there's a better one we can look at. I think 304. Yeah, that's the guy. We have these like pretty nice looking filaments right here. Some prominences over here. These are just little like layers of plasma that are just like dancing along. And you can kind of see it right here. I can't put this in motion or anything, but it's pretty cool to see that. Also want to check out 211, which highlights any coronal holes. Nothing huge. I mean, you have one on the west limb right here, but it's way up north there. So I'll keep an eye on this for the most part. I don't see any big storms in our forecast. We have a R1 radio blackout, which is going on right here due to some flaring, but I just don't see anything huge here. And this kind of highlights the flares we had last week. You can see we did actually get a few CMEs out of this as 4366 was punching its way back to the west limb. I didn't really talk about it because we were cloudy this whole time, but nonetheless, pretty cool. I'm going to go back to what the sun looks like right now. And again, looking at the newest data, the only active region I'd be watching is over here on the east limb, maybe in the center disk right here. That's our big bad boy over there, 4366, which is still showcasing some pretty crazy, like, look at how beautiful that a little bit of streamers coming out of that. I mean, it is a beautiful one. I won't lie. Look at that. Wow. That is so pretty. But nonetheless, a couple other active regions are right here. As I mentioned, you can actually almost see that filament right there going right across center disk. So that can launch itself and create its own solar storm, if you will. So that's why we watch filaments. They don't always have to be associated with big sunspots. And all sunspots do is they magnetically are tied together like that. And then when you have plasma that lifts off, the whole thing, it like builds. It's like a boiling pot, and then it lifts off. So that's what we're looking for when we're looking at space weather. But otherwise, you guys have a great rest of your week. I will see you next week for any more space weather news.